Now I want to step up the complexity just a little bit for you. Don't worry, we're not going to be using this right away. I'm sharing this with you because we will use it later in the class, and I'm going to call you back to this. So we'll kind of learn this and do some other stuff, and then we're going to circle around and actually use this down the road a little bit. So nested list, when you hear the word nested in any computer programming language, especially in this class, I want you to think of these Russian nesting dolls. You know how these work? Seen these before? Okay, so if you travel to Eastern Europe, Russia, or any of the countries that used to be part of the Soviet Union, especially, but other areas there as well, you'll see these, and they're often handmade. And the number one way to tell the quality of these is how many dolls you are inside, like how many layers there are. And the way they work is each one of these dolls comes apart. They're made of wood and they're cut. Usually you can't tell because they're very intricately hand painted. And you take them apart and you put the next smallest one in it. So you take this little tiny one and you put it inside there, and you put this one inside there, and this one inside there, and this one inside there. You get the idea, all the way until they're all inside that big one. And that's what nesting means. Okay, it's this idea of putting something inside something. And when we have lists that are nested, this is what it looks like. Okay, so I have this list called L, and inside that list, there are 3 levels of nesting. At the top level, or level 1, there are 5 items. Okay, 5 items. What item is at index 0 in list L? A. Good. So index 1 is B. Here's the tricky one. Index 2. What's at index 2? Say it again. That is right. It is actually, or you could just say a list, right? Because that list has 3, it's a list that contains 3 items. So it's this. This is, if I print this, L index 2, it will print this, right? Which is another list. And then we have 3 and 4. So those are the 5 items in list L at level 1. If we go into this list here, this list has its own index. 0, 1, and 2. So if I print L2, index 2, which is that whole thing, and then I say I want inside that list index 2, then it prints just this list here. So you can see I'm kind of burrowing down into this structure. That's what we refer to as a data structure. Sometimes it's called a tree, because if you map it out a certain way, it looks like a tree. I'll show you that in a minute. And inside this list, there are 2 items, 0 and 1. So if I print L2 to 0, oh, it prints E, because that's what we have at 220. And you might be thinking, why on earth would you ever want to do something like that? There are some really useful cases when you're dealing with more complicated data, when you will want to do that, when it makes absolute sense to do this. Here's another look at that same nested list, right? Now you can see it's broken out so that each sublist is its own thing. And you can see A, B, this list. I don't know why it's GH. I don't know. Did I put GH up there? Maybe I did. I can't remember. But we have in that list C, D, and a blank space, which contains this list. And you can see the indexes now. Now you can see this is very simple, but if we had more stuff there and more lists and bigger lists, you can kind of see how it would branch out like a tree, like an upside down tree. And that's where it gets the name tree structure.